Alright, your Army Research Laboratory BRL CAD Tutorial Services Tutorial Series Volume 3 Principal Effective Modeling Lee A. Butler, Eric W. Edwards, Dwayne L. Kregel, ARL SR 1119, September 2003. Approved for public release distributions unlimited. Alright, the Principles of Effective Modeling Volume 3. Alright, list of figures, list of tables, acknowledgments, introduction, model processing, the importance of model mission, model MODEL, 5 steps approach to creative effective models, measuring data, organizing structure, developing geometry, evaluating geometry, locking documentation, references, using a pipe primitive, using projection shader, using extruded pipe bitmap primitive. Appendix D, setting up a MGEDRC file using a building pattern tool, and Appendix using the build and region command. Those are the appendixes. List of figures, acknowledgments, supplementary. The HAT stands for Supplementary Tutorial Boxes. Note that tutorial boxes have been used throughout the document to supplement this information presented next. Each of these boxes is designated by a graduation hat icon. Alright, your introduction. Since 1979, the U.S. Army Research Laboratory had developed the U.S. Army Ballistic Research Laboratory computer-aided design, constructive solid geometry, model packaging with a wide range of military and industrial applications. The package includes a large collection of tools and utilities, including interactive geometry editor, ray tracing, generic frame buffering libraries, network distributed images processing, signal processing capabilities, and embedded with a scripting language. As a part of the multiple volume tutorial is under development, to assist you with the menu of the featured BerlaCAD package. The Volume 1 provided an overview of the package contents, installation, Butler, Edwards, 2002, Volume 2. Just the basic feature of the functional package of the multiple device geometry editor. Offers a comprehensive list of users' command availability. Butler AL 2001. The documents are available for download at ftp.arl.army.mil/berlacad and less than greater than U.S. Army relay. The purpose of Volume 3 is to discover the components of model processing, suggest the principal maximum effectiveness, BerlaCAD's capability to cover the larger diversity of the model project with principles have a large band kept with the general nature so that they have the widest applicability possible. In addition, several appendixes have been included to offer detailed discussion about the several BerlaCAD's tools and features, including pipe primitive, Appendix A projection shader, Appendix B extruded bitmap primitive, and Appendix C the MGEDRC file, Appendix D, the pattern tool, the Appendix E, and the build region command, Appendix F. Alright, your future volume of the tutorial series plan to discover the geometry focus, geometry format conversions, advanced modeling featured program options. 2.1 Modeling process. The importance of model mission, but the key to knowing how to build successful, effective the BerlaCAD is know why you want to build, is to know why you are building them. For this is for the measurements are taken before any structures are laid out, before any geometry is built. The modeler should, if possible, meet the program sponsor, the participants, and/or end user of the game with the understanding of the model's intended purpose for that is its mission. Whether the model is intended for the ballistic analyst for the radar study, for something else, for the model's mission should be based for the determination of how all the parts of the modeling process should be conclude with the level of detail modeler should achieve the tree structure of the model should have the amount of the modeling time link that be alive with the type of the validation verification of the model shall have the even with the way of the documentation shall be created logged. This point may seem obvious, but failure with the preserve of the acknowledgement can be resolve the waste of time and resources ultimately in an effective model. For example, the one creating the geometric target description of the combat vehicle simulate with the ballistic penetration and eventually accurately model the material thickness of the density of the outside armor with the crucial with the analyzing penetration damage. In addition, usually important to include the internal component of the fuel and electrical lines, ammunition, even crew members, in which greatly affect the vehicle's functionality if they are impacted by projectiles. See Figure 1. Radar signature studies, on the other hand, are often called the different type of the model for most of the part with the vehicle's outer shell and or skin. And what is important, previously mentioned that armor thickness with internal components are usually unnecessary. This shows the crew, show the ammunition, the convenience, the continuous track and individual track liners links are often not modeled for ballistic studies. Ballistic penetration model with transparent exterior. No, individual track link scan detail is important with the radar study. For the surface observer, the detail is often necessary. Figure 2 shows the external detail commonly used with radar signature models. It's also important to note that the sub-models will need to serve multiple missions and modular subject will okay for the model, but it should be built with the highest levels of the detail, with any of the intent, with the U for the end that will occur at the time response permit. Alright, 2.2 MODEL, 5-step approach creating effective models. After one of the explicitly unequivocally established why over the model and how over the model can be addressed. Unfortunately, no signal of the universally accepted method of creating a model for the rarely cut. In fact, with the professional modelers are known that they employ many unique techniques to accomplish the equivalent result, but nonetheless, they are several basic steps of the procedure that commonly used with most modelers to create an accurate, realistic, useful geometric representation in time and efficient manner. But these steps should be described in various variety of ways community that can be generalized with the following 5 categories represented with the acronym model. M. Measuring, collective converting data. O. Organizing the structure. D. Developing building geometry. E. Evaluating, checking geometry for correctness. L. Logging or creating documentation. Remaining sections of the document are addressed each of these steps in turn. As shown in Figure 3, the modeling process can be thought of with a wagon wheel with the 5 spokes. Each spoke is extended out for the inner hub. The model mission is equally important with the give of the wheel with the strength and functionality, although so are the common to the conservative step in order that they are listed. And M, O, then D, then E, and then L. The modeling process of the dynamic is not unusual, but this particular phase that occur with a different order to be skipped together as it develops. So you have measuring, organization, development, evaluating, logs. For example, the organization phase is often the first step of the large but the complex of the modeling project because it is the modeler step of the tree structure will guide the collecting measurement of the right on the right of the model of the data. The modeler often defects the measuring inaccurate data with the geometry development phase, which requires the returning of the measurement phase. Finally, case involving the conversion of the geometry from another source for the measurement and the development phase. The non-applicable modeler might skip directly to the evaluation phase. All right, 3. Measuring data.